Okay, so the rational zero theorem is something that says every polynomial function that has integer coefficients, that's what that means, integral coefficients, every rational zero that you could write as a rational number, right? That means like 1/2, 3/4. It doesn't mean square roots. Will always be a factor of the constant term over the factor of the leading coefficient. So that's what all this says. I lost my pen. Where you take, so we might want to say this, P over Q equals, oh look, it's down here. Factors of the constant term over factors of the leading coefficient. So maybe we won't write that. What does this mean? When you're looking for zeros of a function, instead of just having to randomly guess what those zeros could be, you can make a list of possible, or sometimes they say potential rational zeros by just taking factors of the constant over factors of the leading coefficient. And sometimes it's still a pretty big list, but it definitely is better than just picking every number possible and trying to find a zero. Okay? So if I gave you this problem, and the first part of your homework today is like this, it doesn't say to actually find the zeros, it just says make a list to see if you know how to do this. It even says in the directions, do not find them. Just see if they work. So if we want to take factors of the constant term, what is the constant term in this problem? Yeah, the constant term is the number at the end, the one with no variable with it. So maybe you want to write that if you don't know that. So the constant term on this one would be -2 over factors of the leading coefficient. What's the leading coefficient on this problem? Yeah, the leading coefficient is the number in front of the highest exponent. So the highest degree is 3, so the leading coefficient is 15. So I need to take, maybe I should write, factors of -2 over factors of 15. So what are the factors of -2? Yeah, factors just mean numbers that multiply together to give you 1 and 2. Do you agree that, and once we do this, I think it's going to come back to you that you've done this before. Do you agree that signs, like it could be 1 times -2, or it could be -1 times +2? Both of those would give you -2. So you could actually say plus or minus 1, plus or minus 2, because factors of 1, factors of 2 would be plus or minus 1, or plus or minus 2. You always put the plus or minus with it. Over factors of 15. What are all the things that can multiply together to give you 15? 1, 3, 5, and 15. And I'm going to put plus or minus. Plus or minus 1, plus or minus 3, plus or minus 5, plus or minus 15. So all the rational zeros that could exist come from putting these together. So now what you have to do is go through and actually write out all the possibilities. So could we go through and put 1 over 1, 1 over 3, 1 over 5, 1 over 15? What? I don't like this. Wait till we have to find them, kids, if you think this sucks. This is the easy one. Wait a minute, we have to write, like, just write all the numbers that could exist. 1 over 1 is plus or minus 1. That's one option. Okay. 1 over 3 is plus or minus 1/3. That's a little bit better. I thought you meant like we had to write 1 and then -1 and then no. Plus like positive 1/3 and negative 1/3. No. We just need to write all the possible actual numbers out of it. So 1 over 5 is plus or minus 1/5. And 1 over 15 is plus or minus 1/15. And then we have to go back to the 2's. And if you ever do something that can reduce down to be something you already have, like if you already have 1/2 and then you got 3 over 6, it's the same thing. You don't have to write it again. I'm not going to mark you wrong if you do, but there's no need to do that. 2 over 1, that's just 2. 2 over 3, that's 2/3. 2 over 5, that's 2/5. And 2 over 15 is 2/15. What does this represent? Possible zeros that could work in this problem. How do you find them? You just get to start guessing, right? Like you just get to start plugging them in, which is why we have the remainder in the factor theorem to be checking what gives us 0. Okay? But part of your homework today, you're just listing them, and on the ones that you do actually have to find, you shouldn't have like 20 of them to check, unless I want to be super mean. which I don't think I feel super mean today. Rachel might disagree after her calculus test that she took. But. You know where Sean is today? I know you're not his keeper, but why does he miss so much school? I'm very concerned. My goodness. My goodness. He doesn't even remind me anymore. Does he have a Facebook? Sean doesn't seem like a Facebook kind of guy. I'm gonna find him on Twitter and send him a message and tell him to get his bunch of school. You know, he has calculus. He's missed more calculus than anyone else. He's missed 4 days. Which he did have his little concussion. Yeah. He missed like the whole week before Christmas break. And then we had 3 weeks of Christmas break. So he really was like out of school for a month. Oh no, I want Sean to be here. Sean's gonna get credit on the AP exam if he just comes to school. Like he's a smart cookie. So you know he came back he's pretty good. He asks me lots of hard questions that drive me crazy, and then I try to answer him, and then he gets mad at me, and then we like seem like we're about to fight. But this is my favorite type of problem to do PRZs because what would I take factors of on this one? Factors of 15 over factors of 1. So when the leading coefficient is 1, that means you're not going to get any fractions, right? So if I was just going to list these, I'm going to take factors of, you don't have to write this every time, but factors of negative 15 over factors of the leading coefficient, which happen to just be 1. Which means I could write all this over 1, but I don't need to, right? Because when you divide by 1, nothing changes. Which means that's my kind of problem, when I could check to see which ones of those worked. Do you have any memories of this? Yeah. You did this stuff. And it's a big freak out. This good quiz will counteract the bad quiz, right? Hopefully. Okay. No, I didn't do that. Are you going to No. Amber's supposed to take hers, and Taylor was supposed to finish her today, and she's not here, so. Well, I know, but I've had other stuff to grade, and, you know, I just had to live in the top 5 priorities. Yeah, right. You're fine. You'll be okay. They'll still squeeze in here. So what else can we do to help us figure out how many zeros something has? Descartes rule of signs is a way to help you, and I looked through your book last night, and I did not find Descartes rule of signs, but guess what? On your unit test, there's a problem that says use Descartes rule of signs, so I thought I better teach it to you. I find this IDTech class to be a little shady sometimes, but Descartes rule of signs, this is the real reason that I decided to print your notes out when I put this on there, because I knew you would all just cry if I made you write this. But basically, you can determine how many positive or negative real zeros that a function may have, which means you could also use it to find imaginary. But on your unit test, they ask you a question that says, use Descartes rule of signs to find the possible number of positive real zeros and negative real zeros. So, I'm going to show you this, and then we'll actually do one. But it says, if you have a polynomial function, the number of positive real zeros is the same as the number of changes in sign of the coefficients of the term, or is less than that by an even number. And I think maybe you would vaguely remember doing this if I wrote, let's just do a really easy one here. If I wrote f of x equals x cubed minus 2x squared plus 3x minus 7. To find the number of positive real zeros, you just look at the signs. That's why it's called the rule of signs. Do you agree that this is a positive number? This is a negative number. This is a positive number. And this is a negative number. And you just count how many times does it change sign. Does it change sign here, positive, negative? Yep. Does it change sign here, negative, positive? Yep. Does it change sign here, positive, negative? Yep. So it changes signs 1, 2, 3 times. So we could say that there are 3, or you have have to count down by an even number. So you always go down by 2 until you can't go down anymore. So you would say there are 3 or 1 positive real zeros.
Wait, hold on. Repeat that what you just said about 3 or 1.
That's this part right here. 3 is because it changes 3 times, but it says it's equal to the number of changes in sign or is less than this by an even number. So however many sign changes you get, you have to subtract 2 until you can't subtract anymore, or you would be negative. So let's say there were 4 sign changes. You would say there are 4 or 2 or 0, because you can just keep counting down by 2.
So you subtract it by 2, but it can't go to negative.
Right, because you have a negative number of
So
zeros.
it could be 1 or 0.
Yes, every time it should end in 1 or 0. And you do the same thing for negative real zeros. You still count down by 2, but the difference is you have to change, like you have to plug in negative x and see what happens. So it says the number of negative real zeros is the same as the number of changes in sign for negative x or less than this by an even number. So it's really easy to do this one as well, because when you plug a negative into an odd exponent, is it going to change the sign or keep it the same? Right? You shouldn't have to actually do the work on this. If you plug in a negative x in for an odd one, I have to plug it in for all of these. If you plug a negative x into an odd power, won't it always make it a negative? Like it changes the sign of it because it's odd and it's extra negative left over. But what about an even power? When you plug a negative into an even, does it change anything? It doesn't change. So for me, I don't actually do this step. I just look at it and say, well, this one was odd and it was positive, so now it's going to be negative. This one's an even power. An even power is not going to change with this, so it's going to stay negative because that's going to stay the same, and then it's still going to be negative 2. 3 times a negative x, that's odd, that's going to change to a negative. And this 7 cannot change because there's not even an x in it, which means all of these end up being negative signs. So we would say there are 0 negative real zeros. In pre-calculus, when we do this, I always say I don't care if you use Descartes rule of signs because it can help, but it's not really required because you can still find your zeros without it. But why is it helpful? For a problem like this, if you have your PRZs all worked out, if you know there are no negative numbers, do you agree you could eliminate all the negative PRZs that you just found? So that's kind of nice. Like if you know that, you can be like, oh, I don't need to check any negative numbers, I just need to check positive. There is a question on your unit test over Descartes' rule of signs, so we need to be practicing it so that we can get that question right on our unit test. Okay? I'm going to do it today as we do the other stuff. Okay, so let's actually put all this together. What can we do with the problem with this? So part of your homework today says list all the PRZs. The second part of your homework says actually find the rational zeros. So if you're going to find the rational zeros, let's use Descartes' rule of signs to practice, but you're going to have to not only list your PRZs, but you're going to have to check them and see which ones work. So that's where like having a calculator nice and handy would be helpful. So let's start with Descartes' rule of signs. If I do Descartes' rule of signs, I'm just going to go through here and I'm just going to say positive, positive, negative, positive. I'm just taking the signs. Positive, positive, negative, positive. How many times did that change signs? Yeah, it changed 2 times, so we can say that there are 2 or 0 positive real zeros. So there could be 2, or there could be none. And for the negative ones, I just go through and change the signs of anything that has an odd power. If it's even or the constant's not going to change. So x to the third, is it going to stay positive or is it going to change to negative? Because it's odd, and so odd changes when you plug a negative in. So that's going to be negative. What about x squared? Is it going to stay or change? Stay. about this x to the first? Is it going to stay or change? It's odd, so it's going to change to positive, and can 21 ever change? Which means, how many times did it change signs? Do I say 1 or 0? You just say 1, because you can't make 1 go down anymore, right? So 1, negative, real, 0. Okay, so that's Descartes' rule of signs. What we really want to use is the PRZs, and I kind of picked a nice easy one here that just has a coefficient of 1. But let's list our possible PRZs. I'm going to write, that's number 1. I'm going to write number 2 down here, so in case you're like doing your notes, you'll know what goes with what. But PRZs, I'm going to take factors of the constant, which is 21, which would be plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21, over factors of the leading coefficient, which happens to be what? Hooray, we know the check fractions. Sometimes when I give you an odd problem in the book, people like to just magically think like, oh, I picked it on the first try, which one works? I'm on to you. I know you're going to do that. But that's find the PRZs. We did it because it's over 1. Step 3, you have to plug them in and see what happens. You need it to work, which means you need it to equal 0. You have 2 options. One option is you could synthetically divide all those ones until you get something that works. The second option is what we did yesterday, which is the remainder theorem that says, can I just plug in these numbers until I get 0, and then I'll know which one actually works in the problem. So if you want to synthetically divide, by all means, you're welcome to synthetically divide. But when I do this, I'm just going to start with 1. I always hope that 1 works because it's easiest for me. And I'm just going to plug it in and see if I get 0. So if I plug 1 in there, I get 1 plus 3 minus 25 plus 21. 4 plus 21 is 25, and 25 minus 25 is 0. I did it. I always start with 1 because I always have the hope that 1 works. Like it just makes me, like every time I think this is gonna work. Sometimes it's a stupid fraction that works, and I check all the other ones first. I really didn't know it was gonna work. So here you have options, okay? We want to know which rational zeros work, which means we could just go through and check 2, 4, 6, 8 of these. Yes? And just list of those 8 which ones gave you 0. And you have a calculator, you could do that. Eventually, I'm going to want you to find all the zeros, including ones that are not in this list, like including ugly ones. So I like to show you how you, like, to me, I don't really find it fun just going and plugging stuff in my calculator. That's not really my kind of fun. But you're welcome to do that. On these problems, you can just check all these and see which ones work. Okay? But here's the other option. If I know this works, we can divide it out and look what's left over and see if we could solve that maybe another way besides just guessing random numbers. So what I'm going to do is, since I know 1 works, let's divide out 1 now and look at what's left over. We already know it works, so we should get 0 here. So if I plug in my coefficients, 1, 3, negative 25, 21, look what's left over. I would be left with x squared plus 4x minus 21. I have to throw something at these two. What can I throw? What can I throw? Tried to throw a marker at you, but it went through your legs. Look, it's right beside you. I was trying to hit you in the leg with a marker, but maybe you shouldn't sleep.
I'm trying not to. I'm still writing down what you're saying.
No, you're not. You're just writing down random stuff when you're awake. Look what's left over. This is a quadratic. Do we know how to solve a quadratic without having to just randomly guess and punch numbers in our calculator? Even better, could you factor this quadratic? I love factoring. Which means okay, do all of this. Like, you could do P of 1, you could do P of negative 1, you could do P of 3, like, check them all. But for me, I'm going to divide it out, and then I'm going to say, hey, can I solve this?
Can you only do it if, like, the number 1 works, or can you
You can do it for anything. Like, as soon as you find one that works, like any number that works, you divide out that one number, and what's left over should be something that you can solve. And this does work out to be 7 times 3 is 21, plus 7 minus 3. I'm just saying, if today, if you don't want to do this part, you don't have to. Because today's directions just say, find all the rational zeros that work. Okay, so you could just find them and check them all. But I don't think it's a good idea. So I say, ignore this part. Because you like to do what I tell you to do, and you're going to do this. And I think this is helpful for especially going on next. So it really matters what the question asks you. If the question says, find the zero, so let's write this out. If the question says, find all real, or maybe all rational zeros, you need to write it as like x equals a number, right? Like you need to say the zeros are x equals negative 7, x equals 3, and we found that 1 works, right? And you could have got that by checking all those PRZs. But what if, I'm trying to think how it words it. It says use the zeros to factor f.
wait, so
Yes, so yeah.
we don't actually have to plug in the other things to find their PRZ. We can just
If you can factor it out and use factoring or quadratic formula to find it, you don't have to check them on your calculator. Like, I feel like that's the fastest way to do it, which is why I always show you it. It's kind of like I'm kind of jumping ahead, but I feel like we're going to do that eventually, so you might as well start doing it.
what about P1? Will we not just plug it in at all?
No, because I don't need to. Like, how many zeros could this function have? No. The degree, right? It can't have any more than the degree. So we know there could be 3 zeros. I found 1 0 by just plugging it in. I found 2 zeros by factoring it. So I already found 3 zeros. So can 21 work? No, so I don't have to check 21. If they want you to factor the polynomial, you need to write these as factors and not as zeros. And we kind of already did that, except for which one's missing? X minus 1. So my answer, if I was factoring it, I think this was a P of x, we would say that's the same function as saying x plus 7 times x minus 3 times x minus 1. And if you factored that out, you would get the original problem. That's what we're trying to do here, is get the zeros or get it in factored form. That's exciting stuff, right? A little bit more challenging than yesterday. You're kind of boring. We are. And it goes back to factoring. It doesn't get much better than this, kids. 5-6, fundamental theorem of algebra. It's like the whole point of algebra. It's coming to head for us.
What are you gonna do when it's like black off the black and you're writing with a gradient now?
Throw it at you more. You're so mean. Sit in my class.
I hear you. I literally hear everything you're saying.
You sure didn't move till I threw a marker at you.
I didn't move actually until I had to say, I just threw a marker, or I need something else to throw it up or something like that.
So make sure you pay attention to the directions. On 24 through 30, it's just, oh no, wait, what? Not 30. What did I assign you to? You did 24 yesterday, right?
Yeah.
Oh my gosh, stop. This is not the homework. No homework? 36, 42, to 36 through 42 multiples of 3. The page is right. Yes, yes. Yeah, I was just reassigning. I mean, I could make you do all that, but I think you did some of it already. Like 24, 27, and 30 are just study the maximum number of zeros. Like we did that yesterday. Like I just started at the top, like the wrong amount. And then, so 36 through 42 are just list the zeros, and then 45 and 47, I'm only giving 2 of these. They are actually going to find all the real zeros by using your PRGs, and it says to factor it. All right, tomorrow we'll solve it where we just list out the zeros. Does anybody see Becca or have a phone number that they could text Becca? You do?
Yeah.
Could you text her this assignment? Because someone came and got her homework, and it's totally the wrong assignment. Okay. Or Becca, if you're watching, it's this assignment.
Yeah. Right. Right.